Assalamualaikum. Can you hear me?
Yes, Doctor.
Bismillahirrahmanirrahim. Selamat sejahtera. So we continue our lecture today. By referring to slide number 58, okay, which is a modeling of mechanical translational elements, okay, as shown in the slide number 58. Similar to the chapter 2, when we said mechanical translational element or systems, it consists of a mass, spring, and damper. So I review again for mass. If you have a force to the right, okay, F of T, and the mass is moving to the right with the displacement Y of T. Okay, force. So the force equation will become F is equal to ma. A is the accelerations. Okay, where F is equal to m d square y dt square, differential 2 times of displacement, and F is equal to m dv dt, where v is the velocity. Okay, so all are written here: acceleration, velocity, displacement, force, and the mass. And the next one is the springs, okay, where you have a symbol like this, okay. So K is the spring constants. So when you give a force to the right with F of T, and the spring will be moving to the right with the displacement of Y. So the force will be F is equal to K Y of T, where F is the force, Y is the displacement, and K is the spring constant. And damper, okay, also the same, where you have a force is equal to B dy dt. Okay, B is the viscosity constant of the damper, and dy dt is the velocity, okay, of the movement of the damper, okay, when given a force F of T. Also, we have a modeling of mechanical networks for the rotational systems, okay, where we have a force with T and angular displacement of theta, okay. So this one is the torque, and this one is the angular displacement. Okay. So the force will be torque is equal to J, which is the initial value, okay, d omega t dt, or J is equal to T is equal to J d square theta dt square, which is the twice differentials of the angular displacement, okay, in order to get this value. All these elements of the translational mechanical elements are written in this one table, okay, for spring, damper, and mass with their equations in respect to the force velocity and force displacement, including the impedance. But we used these two, okay, force velocity and force displacement, in order to get the state space representations with the state equations and the output equations. Okay, we move to example 5. Okay, a simple one for the suspension system of a car. So determine the state space representation of the mechanical system below if the state variables are y of t and state variables are y of t, and the second one is dy over dt. Okay, so input system is f of t and the output is y of t. Clear? So as we know that these systems is a second order system, okay? We already derived in the chapter 2 the transfer functions of this mass spring damper configurations of the suspension system is x divided by f 1 over ms squared plus fvs plus k. So fv actually is b. Okay, some books written it as fv and some book written it as b. Okay, so it's given that the state variables have two, which is the first one, xy is the yt, which is displacement. X2 is the velocity, dy over dt, okay, which is dx1 over dt. And the input is u, which is force, and the output is y, which is the displacement, okay. So we draw the free body diagram for this particular systems, okay, from this figure, okay, with the force on the right and the displacement move to the right. So you can write the free body diagram for these systems, okay, where when you give a force to the right, so you can see that there are three force will be opposite to the input f of t, which is the mass, spring, and the damper, okay. And from this free body diagram, you can write the equations of the systems, which is shown here. Okay, this is the free body diagram, one in time domain, one in the frequency domain. Okay, so time domain is t, frequency domain is f, both are the same. Okay, both are the same. But for state space, we are focusing on the A part, okay, this part, okay. This one is for chapter 2 for the transfer functions. So we use Laplace, okay, because in state space, there is no Laplace. Okay, so from the free body diagram, f of t is equal to m y double dot plus b y dot plus ky. Okay, so we know that the, if I can share the, can you see? Can you see? I'm writing. Given two state variables, which is x1, y of t, the displacement, and x2 is dy dt. Okay, which is equal to x1 dot. Am I right? X1 dot.
Yes, Doctor.
So our target now is to find the state space representations, which is Px plus Bu, y is equal to Cx plus du. Okay, so we have to find the derivatives and the output equations. So from the given state variables, x1 is equal to y. So what is x1 dot? X1 dot is dy over dt, am I right? Which is equal to
X2.
x2. And x2 dot is equal to d square y dt square, which is equal to what? Balkis.
X1 double dot.
Negative. Oh,
Equal to what? Derive lah, kan?
yes.
So where to derive is in the here. This one. Okay. Can you see that? The force equations from the free body diagram. So you bring d square y dt square, this one, to the left. Okay. This one goes to the left. And ft will go, sorry, not to the left. The drawings. You bring this one, B and K, to the left. Okay. So meaning that when you bring B and K to the left, so this one, d square y dt square, okay, will be the formula title. And the m constant here in kilogram will be the divider. So divide by m, and divide by m. Okay. So we know that d square y dt square is equals to minus b over m. Okay. Y dy dt minus k over m y plus 1 over m f. Okay. So you can see that here, if I move back to the iPad, okay. So here, the d square y dt square we derive, okay. So you can see that x2 dot now become, okay, what is y? Y is x1. dy dt is x2. And f is the input u. All right. Hello, guys.
Yes, Doctor.
Minus b over m x2 plus f. Okay. So we have a state equation number 1, which is this one. Okay. State equation number 1. And we have a state equation number 2, which is this one. But we must not remember, we must not forget the output. Okay, so the output is y of t, okay, is equal to x1, which is the displacement. So therefore, you can get the state space representation. Who's talking? Please off your microphone. Afzal, itu off-kan mikrofon. So, X1 dot, X2. Kosong. X2 dot minus K over M. Minus B over M. And 1 over M. And then Y of T is this one, 1, 0. Okay. So it will be similar to your slides here. Okay. There you go. Okay. So that is the state space representations of the mechanical translational systems. Okay. Is a second order system. Why second order system? Because the system matrix here, okay, this one, system matrix is, the size is 2 by 2. Okay. If the system is a first order system, so the matrix A will be 1 by 1, the size. If the system is a third order system, the matrix system will be 3 by 3. As shown in the example of RLC last week, the last example of the RLC. Afzal,
Yes, ada.
if K is equal to 1, B equal to 1, M equal to 1, what is the value of system matrix?
Zero zero ada.
0, 0. Tak tahu, tak faham lah tu. Tak fokus. Aisyah Akra, same question.
Yes, sir. Yes, sir. If K equal to 1, M equal to 1, B equal to 1.
What is-
0, 1, negative 1, 1.
Hmm?
0, 1, negative 1, negative 1.
Negative 1, negative 1. Afzal, same question. What is the
Okay.
value?
Yes, ada.
Input matrix. Input matrix berapa? K sama dengan M sama dengan B equal to 1. Masuklah, ganti kan satu ni. Satu.
0 1 ada.
0, 1. Okay, faham tak?
Okay, ada.
Oh, telefon masih berbunyi.
Okay, ada.
Right, so yang ini soalan ni very easy. Okay, this one is very easy, very basic. The real question will be like this. Okay, where you have two mesh, M1 and M2, three springs, K1, K2, and K3, and one damper, for example, with two apa ni, displacement, X1 dan X2. Okay. So bear in mind. Oh, sorry, busy at the class. Okay. We have how many dampers in this figure?
1.
Siapa yang cakap one tu?
Damper ke spring?
Ha? Saya cakap apa tadi? Damper.
Damper.
Damper satu. Salah. Izati, ada berapa damper kat dalam tu? Izati.
Yeah, Prof.
Yeah, from the figure, how many dampers you observe?
1.
Salah. Nurul Hidayah.
Damper dia ada 3,
Yes,
doktor.
Doctor.
Nurul Hidayah, how many dampers in there?
Three.
Ha?
Three.
Tak dengar.
Three.
Hello?
Three.
3. 1, 2, 3. This is a damper and the frictions also considered as damper. Okay. If this one is assumed as 0, meaning that you have 1 damper. But if the friction is taken into account, you have 3 dampers in your system calculation. Understand? Angku Izzat?
Yes, doctor.
How many mass in the system?
2.
Tak dengar.
2.
How many springs in the system?
3.
What is the first step when you want to model this mechanical system in state space representations? What is the first step? Is to draw
Draw the body diagram.
free body diagram. Okay. Okay. So this is the free body diagram that correspond to the M1. Okay. First is force on M1 due only to the motion of M1, and force on N1 due to the only motion of M2. So meaning that both are moving, so you have to split. Okay, and do the directions of the force accordingly, then total up in C. Okay. Then goes to the next one, which is the force on M2 due to the only motion of M2. Force on M2 due only to the motion of M1. So all forces are M2. Okay, in C. Okay, and from there you can create the state space representations. So okay, I'll leave it to you. Okay, you can do it by yourself. Okay, so it will be 1, 2, 3. So we have if the state variables are defined as x1, sorry, z lah. So since the displacement is x1, so we choose state variables as notation z. Z1 is equal to x1, z2 is equal to x2, okay, z3 is equal to x1 dot, and z4 is equal to x2 dot. Okay. Understand? Do you understand? Rita and Rita, do you understand?
Yes, doctor. Understand.
What do you understand?
Because x1 and x2 is the apa? Yang dalam diagram tu. So we let z1 equals to x1, z2 equals to x2, and z3 is x1 dot, z4 is x2 dot. Kita ubah dia punya variable. Thanks, saya faham, doktor.
Pintar, eh? Okay lah. Balkis, what is the order of the system? This one.
Order of the system is 2.
Alah.
Second order.
Oh.
Fourth order.
Fourth order. Okay. Is the fourth order. Okay, mana? Tak keluar. Oh. Okay. Jap. Nampak? Tadi apa saya tulis? Given the SV What is SV, Balkis?
State variable.
State variables. Sorry. Z1, eh? Why I use Z1? Why I use Z? Because the displacement is X. So I don't want to confuse. So I choose another name. Okay, Balkis? So,
Yes.
so you can use B as well. Okay, you can use B, you can F, or whatever names you like. So Z1 is equal to the displacement. Okay, correct? Z2 dot is Z2T, X2, Z3, X1 dot, and Z4, X2 dot. Correct. Okay, so this one we call as what? Fatur Zaki. All of this we call as a tanda tangan, Fatihah.
Ya saya.
All this we call as
State variables.
variables. So the next one will be
The derivative.
derivative state variables, which are x1 dot, x2 dot,
S3 dot and S4 dot.
x4 dot. Yeah. So x1 dot is what?
S1 is equal
Yeah.
to
Not
Z.
x1 dot. Sorry. Z. Sorry.
Oh,
Sekali lagi.
okay.
Z. Okay. Sambung.
Equal to S1 dot.
Slowly. x1 dot, which is equal to
Z2.
z2. z2 dot,
Z2 dot equal to S1
x2
double
dot,
dot. S2 dot.
x2 dot, kan?
S2 dot. Betul.
Equal to z4. Alright.
Betul. Correct.
Next.
X2 dot. Also.
z3 dot. z3 dot.
Z3 dot equal to Z.
X1
betul,
double
betul.
dot.
x1 double dot. Double.
Okay.
Then z4 dot.
S2
X2
double dot.
double dot.
Okay.
Dot. Okay. So we already solved the first state equations, which is this one. We already have two state equation, which is z1 dot and z2 dot. Okay. But this one we must derive from the free body diagram, which is shown in your slides. Yang ini. Okay. Free body diagram kan? So from here, actually, you can you don't follow the S, okay? Just follow the time domain, okay? For example, this one, can K1 plus K2 X1, okay? FV1 plus FV3 X1 dot. F2 adalah force dia kan? So what is the equations you can get from there? Najwa.
Doktor.
Equation, force equation for mass 1. K1 plus K2 X1 plus 2 plus FV1 plus FV2 X1 dot.
Doktor tak share screen ke?
Nanti ya dulu saya
Okay.
Saya tengah tulis, saya share lah. Sabarlah kak ni tak sabar lah. Perempuan tak sabar memang. Sifat dia macam tu. Saya ramai anak perempuan saya tu. Plus. Mass tengoklah tu. C tu. M1 X1 double dot. Betul?
Ah.
Lepas tu sama dengan f of t plus K2X2 plus FV3 X2 dot. Question number 1. Sekarang baru saya share. Nampak? Nampak tak?
Nampak.
Apa yang awak nampak?
Nampak skrin.
Apa equation lah? Equation number 1 tu. So sekarang ni kita nak cari X1 double dot, betul tak? So X1 double dot dia duduk kat sini. So apa-apa yang ada ni, yang ini semua ni, all must move to the right. Correct?
Yes.
Okay, move lah. Move. So it will be X1 double dot. Najwa off microphone. X1 double dot equal to K1 plus K2 X1. Betul? Minus minus. Then plus K2 X2. Then minus FV1 plus FV2 X1 dot plus FV3 X2 dot. Macam itu. Can you see? Boleh?
Ya, doktor.
So sekarang ni state equation yang ketiga, which is this one yang kita nak cari, Z3 dot is equal to minus K1 plus K2 Z1, betul? Plus K2 Z2, betul? FV1 plus FV2 Z3, am I right? Z3 is here. Z3. Ni. And then plus FV3 Z4. So this is a state equation number 3. Okay. State equation number 3. Ini equation number 1 kan? State equation number 2. Dan ini adalah state equation number 3. Ini adalah SE1. Ini adalah SE2. Okay. Okay, lastly adalah yang ini. Which is this one. X2 dot. So kita tanya Nurul Syakila. Nurul Syakila.
Yes, Doctor.
X2 dot. Go to the next one. Yang ni. Okay, you give me the force equations from the figure shown there. Kiri, 3 force on the left equal to the 2 force on the right.
Yes.
K2 plus K3.
X2.
2 plus
FV plus FV3. FV3
plus FV3
X2 dot
x2 dot
plus M2 x2
M2
double dot
x2 double dot
equal to
equal to FV3
FV3 x1
plus
plus K2 x1.
x1. Okay.
Doktor,
Ini saya.
for the previous one,
Hmm.
for the x1 double dot,
Hmm.
do we need to divide with M?
Divide with M.
Hmm.
Yalah, all of it. All of it.
Okay, doktor.
So very busy the class. Okay, so you divide by M. So I share again.
Excuse me, Doctor.
Wait. All divide by M kan? Shakila?
Yes, doktor.
Yes. Who's asking?
Asha Akram.
Hmm.
Just now I couldn't understand because I always wonder why FS dia pergi mana FS tu yang dalam body diagram tu. So saya tertanya FS kan anak panah tu ada dia tulis FS kan. Saya tak berapa faham yang tu.
FS tu F
Tak perlu masukkan ke
dalam mana? Mass 1 ke Mass 2?
mass dalam A and C punya diagram.
Dalam E and C.
Yes.
Mana ni? Which one you are talking about? I tak faham.
Soalan yang slide 73
Salah
kan
satu.
dia ada
Okay.
kan dekat A dengan C tu dia ada FS kan, ada variable FS. So saya selalu tertanya FS tu tak perlu include dalam equation juga ke macam mana?
FS tu dah
Dia pergi mana? Macam tu lah.
FS tu ada dekat M1 tu. Ni.
Oh,
Ada.
okay.
Akak tak
Okay.
nampak ke? Oh, mungkin saya kena lukis macam ni. Buku ni daripada buku. Patut dua ni dia tunjukkan sebelah sini. Dia keliru lah. Tapi kau tengoklah anak panah tu.
So kiranya, okay, get it. Okay. Thank you, Doctor.
Kak ni tak sarapan lagi ni. Okay. Dah So Z3, Shakila, thank you for the M1. So now we move to the what do you call that? Yang ni tadi. Okay. Nampak? Yes. Okay, this one Shakila.
Yes, doktor.
So now we want to find this one, which is equal to Z4 dot. Am I right?
Yes.
Z4 dot yang ni. Z4 dot ni. Kan?
Yes.
Okay, so this example is not being solved. So I give you the solution so that you understand. Right, so now we move it x2 dot. Okay, is equal to macam mana? K2 x1. So we rearrange negative x2 plus FV3 x1 dot plus FV2 plus FV3 x2 dot, and all divide by M2.
Doktor,
Hmm.
minus for FV2, FV3, right?
Betul. Okay, saja nak test tidur tak tidur. Bagus, tak tidur pun. Yang lain semua tidur. Okay, negative So, from here, we can replace it with the notation Z4 dot is equal to K2 M2 Z1 K2 K3 M2 Z2 plus FV3 M2 Z3 minus FV2 plus FV3 M2 Z4. Okay, so now you already derived the Z1, so this one will be the fourth state equations. Okay, so meaning that Z1 dot, Z2 dot, Z4 dot, okay, masukkan A tu. F. Okay, Y of T is equal to usually X1 lah. Okay. Okay, usually output is Y of T is equal to X1. So this one will be 1, 0, 0. Okay. So this one will be 4 by 4 metric system. Can you insert your own inside this box? Henrietta?
Yes, Prof.
Can you
Yes.
insert in the box? Okay.
Okay.
All the equations, the coefficients. Can,
Yeah, can, Doctor.
Can, Thank you. Can you do it now?
Wait, Z1.
Can you do it now?
Now, on the spot.
Right on the whiteboard.
Okay, Doctor, I'll try.
Tak
I'll
boleh,
try.
boleh. Virtual tak boleh.
Oh, wait.
Saya seorang je pegang pen. Faham tak? Do you understand? Okay. So Aina tolong bacakan slide 75. Aina,
Ya, Prof.
Aina 2 harakat.
Figure
Dua
below
harakat
shows a
depan, 2
diagram.
harakat di belakang.
Figure below shows a diagram for a quarter car model, one of the 4 wheels of an automatic suspension system for a long distance bus. A good bus suspension system should have satisfactory road handling capability while still providing comfort when riding over bumps and holes in the road. When the coach is experiencing any road disturbance, such as pothole, cracks, and uneven pavement, the bus body should not have large oscillations, and the oscillations should be dissipated quickly. I draw the free body diagrams of the system to determine the state space representation of the quarter car system by considering the state vector and the displacement of bus body mass M1 as the output of the system.
So Ibal, Saad. Sohibal. Tak datang, absent.
Yes, doctor. Yes.
Where are you? Bolo, bhai.
I was muted and I didn't know.
Good sleep, huh? I know you in Bangladesh. So what is
Yes.
this?
Um,
What? Don't know, don't waste time. My Sarah.
Yes, Prof.
Same question.
Sorry, Doctor.
What is power of T in the equations matrix?
4.
Huh?
Power of
Tak dengar lah suara. Kuat sikit Mas Sarah. Tak tahu.
Doktor.
Sharifah. Apa?
Ya,
What is power of T, Pa?
transpose.
What is transpose?
Transpose dia terbalikkan
English.
the order.
English. Your friends don't understand.
The row becomes column.
Zeros become column. Oh, you mean like this? Wait, Interchange between row and column. Am I right?
Yes.
Interchange. That is the correct word in English. Saibal. Saibal.
Yes, Doctor.
Interchange between row and column. Do you understand?
Yeah. Since this is 4 by 1, it will be 1 by 4.
State variables, Z1, Z2, Z3, Z4. Okay. This is state variables and the state vector is Z, K, which is equal to X1, X2, X1 dot, and X2 dot. Okay. So in this case, there is no power of T, but you can wrote it like this. Power of T. Okay. Same thing. Okay. Is it okay?
Yeah.
So I have to close the video because it disturbed the bandwidth of the lecture. Okay. So there you go. Okay, can you see? So what is the output of the system? Balkis,
Yes, Doctor.
what is the output of the system?
Output of the system.
Uh-uh.
YT.
Yeah. YT. Mana ada YT sini? There is no YT here. Where is the output of the system?
Output
Ada
of the
tulis tak?
system. Oh, displacement of body mass, M1.
What is it? What is it? Y equal to X1. Okay.
Okay.
Y equal to X1. What is the input? Balkis?
Input is X1, ZT.
X1 Z. Astaghfirullahaladzim. Salah tu. Ada kat depan tu. Ya.
ZT
Ni. Input.
or UT. UT.
Force. Okay. The force is applied on M1. Okay. So it is similar to the previous case. Okay. And we have a 4x4. Apa nama ni? 4x4 system matrix expected, because we have a 4 state variables and 4 derivative state variables. Okay, so this is the figure. You have a 2 displacement, x1 correspond to m1, x2 correspond to m2 displacement. 1 input force at u of t, and this is a road profile. Okay, this is your road profile. Okay, ini is a rural area road profile, because it's not straight, it's not highway. Okay, and the value of M1, M2 is given 2,500 kilogram, 32 320 kilogram for M2. Spring constant of suspension system. K1 80,000, K2 is 500,000, damping constant B1 and B2 is given as shown in slide number 78. So you draw the free body diagram again, like just now. Okay. So you can see that for M1, due to the motion of M1, U is equal to K1 X1, M1 X1, and B1, M1 X1 double dot, B1 X1 dot. Okay. And for motion, for M1, due to the motion of M2, you have a 2 here, K1 X2 and B1 X2 dot. And this one is total 3 force on the left and 3 force on the right. Okay. So what is the force of equations here? Aisha Soleha,
Yes, Prof.
what is the force equations for M1? Total.
First equation.
Force equation based on M1 free body diagram.
K1 X1 plus M1
X1 double dot
X1 double dot
plus
plus
B1
S1 dot
plus B1,
plus B1 S1 dot
okay, equal to,
equals to K1 X2
teruskan.
plus UT
Mhm.
plus B1 X2 dot
Bagus. Very good.
double
Double dot dot
dot je.
dot je. Dot je. Okay, so M2 also the same. Okay, same concept. And then the state variables are here: Z1, Z2, Z3, Z4, X1, X2 dot, X1 dot, and X2 dot, and derivative Z1 dot equal to X1 dot equal to Z3, Z2 dot equal to X2 dot equal to Z4. So we have the two state equation already. And we have to derive the X1 double dot and X2 double dot. Similarly, like previous example. Okay. Then total force for M1. So we insert the value to simplify the notations. So it become Z3 dot. For M2, we insert the values and we got Z4 dot. Then we rearrange Z1 dot, Z2 dot, Z3 dot, and Z4 dot. So we will get a final value of the state space representations. Okay. You understand? Any question to ask? Zakari? Any question to ask? Zakari?
No, that.
Think clear? Clear?
Yes.
Shuhada? Shuhada? Tak datang? Tak datang. Aisyah Syahira?
Yes, Prof.
Any question?
No.
Okay,
for
I
now.
have a question for you. I have a question for you, Syahira. What is the size of system matrix in slide 84?
4 by 4.
Why?
4 by 4.
Why?
Hello?
Why 4 by 4?
Oh. Why 4 by 4? Oh, okay. Because there's 4 rows and 4 columns.
4 columns. Matrix B size?
4 by 1.
Matrix C?
1 by 4.
Matrix feed forward? Matrix feed forward size there?
No. Then
Huh?
there's
Huh? Metric feeds forward not exist.
Okay.
Tak kira kena kelabar. Tahu. Are you ready for the test? Balkis, when is the date of the test?
Minggu depan.
English.
Next week.
Next week, bah. What date?
I forgot.
Astaghfirullah.
Whether it's Tuesday, Wednesday, or Thursday.
Akram, what is the date of the test?
For system modeling,
Hmm.
1 December, if not mistaken.
Mana ada 1 December? 1st December.
1st December, pardon.
Lebu English budak-budak ni. Betul ke? 1 Disember? Hello?
Second.
Sah?
Salah.
Sorry, second. First two
December.
microprocessor. Sorry.
Betul.
Second
Second what? 2nd December.
December
Which is on
2021. Which
Thursday.
is, yeah, correct.
2nd December, Thursday. What time, Aisyah?
9 p.m.
9 p.m. Until?
Is it? Correct.
Until 10:30. Okay, how many questions? Nazmi, how many questions for test 1? Tak datang. Irshad, how many questions in test 1? Tak datang. Oh, ramai tak datang ni. Sedap sikit ni. Pangkal. Akmal, Husaini, how many questions? Tak datang. Isma.
Yes, Doctor.
Banyak member kau tak datang dah pangkal ni. Siap lah besok dapat surat. How many questions in test 1?
I don't know, Doctor.
Huh?
I don't know.
No idea.
Is it four question?
3 questions.
Yeah.
3 questions for test 1. Okay. 3 questions. For marks 15%. 15%. Question number 1. Transfer function modeling, RLC network. Question number 1. Question number 2. Transfer function modeling of mechanical translational system, mass spring damper. Question number 3. State space modeling of RLC network. Balkis, can you repeat again?
First one, transfer function for RLC
Network.
network. Second, transfer function network for mechanical spring mass damper. Third question, RLC circuit for state space.
State space modeling.
State space modeling.
Aisyah Shahira.
Yes, Prof.
Is it our lecture today include in the scope of test 1?
No.
No, doctor.
No.
No. Okay.
Okay.
So as usual, question will be downloaded in e-learning. Okay. Then you will answer the question and I will give the link Zoom. Okay. So that I can monitor you. 9 p.m. Okay. So actually I trust you lah. So you have to make sure that don't use no copyright, no calling, no Roger, no what is called the software tu? Apa software tu? Software yang meniru tu.
Check, Prof.
Check software. Do not use check software. Okay, so do not use check software. Okay, that's all. Thank you very much. Any question? Ada
No,
soalan?
Doktor.
Tanya.
Prof tak ada ke bagi kasih apa tu sample test ke like questions lah.
Ulang
Or
kaji.
just-
Ulang
Ah.
kaji. Boleh.
Okay, thank you, Prof.
Wednesday.
Boleh. Oh,
InsyaAllah Wednesday. Kan lah?
Can.
Prof, can.
Lambat lagi ke? Habiskan dulu lah. Habiskan. I finish this chapter first, then I will make a revision. Test 1
Okay.
revision. We call it test 1 muzakarah.
Prof, untuk test 1 ni sampai mana dia?
Sudah aku cakap tadi, Pak.
Sorry Doktor, tadi tak dengar jelas saya tengah ada.
Balkis, can you repeat again?
What, Doctor?
Repeat
The question. Question 1 for RLC transfer function system. Second question, mechanical transfer function. For third question, RLC state space model.
Siapa tanya tadi?
Ihsan, Doktor.
Ihsan Aulia. Kamu dengar dong? Kamu di mana nih? Bogor ya?
Ya, Doktor.
Itu skopnya. Skopnya saya ulang balik. Q1 transfer function modeling RLC network. Number 2 transfer function modeling mechanical translational system. Number 3 state space modeling of RLC network. Apa beza Ihsan between question 1 and question 3?
Saya pun baru nak tanya, Doktor. Tadi coba ulang, Doktor. Question 3 tu tak ada apa? Apa space tadi, Doktor?
State space modeling. Question 3 state space modeling which have a matrix. Okay.
Ya, Doktor. Yang dengan matrix tu.
Ya, transformation modeling tidak ada matrix. Dia ada fraction, numerator and denominator.
Transfer function dengan
on Wednesday. Okay. Revision until you understand.
Ya, terima kasih, Doktor.
Any question?
Lagi, Doktor.
Ada soalan? Thank you very much. Okay. Bye-bye. Thank you.
Bye, Doktor.
Prof.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Bye-bye. Bye-bye.